Morning, this is your Stat Sensei, Mr. Spensei, and this is Death Packet Unit 3B, Probability Distributions, and this will be problems 51 through 60. So Review Book A advertises an average SAT score of 40 points. So with A, we have a mean of 40 and a standard deviation of 12. Review Book B advertises an average gain of 35, so a mean of 35, and a standard deviation of 15. Assuming both assertions are correct and assuming normal distributions, which review book is more likely to have an SAT gain of over 60 points? So we want the probability that X is greater than 60. All right, so I have a mean of 40, standard deviation of 12. Let's calculate these probabilities. And we're going to do this by using a norm CDF. So second vars, norm CDF, lower bound. And by the way, I should go ahead and draw the pictures just because I think that makes a big difference in people's understanding. So my quick mean is this is 40, this is 60, and I'm shading up to infinity. On this one, I have a mean of 35, which is a bit lower, but we have different standard deviations. And I'm shading up, have it, we want a value of X of 60 and we're going up to infinity. So here we go. Lower bound, 60. Upper bound, 9.99. Mean, 40. Standard deviation, 12. And I get 0.04779. When I run the next one, second vars, normal CDF, lower bound is 60 because that's what we have shaded. Upper bound is infinity, 9.99, but our mean is 35 and our standard deviation has been changed to 15. And I get 0.04779, which is exactly the same thing. For both plans, the probability of an SAT score gain over 60 is the same at 0.04779. Answer choice C. Number 52. In the Dominican Republic in August, the distribution of daily high temperatures is approximately normal, with a mean of 86 degrees, and approximately 95% are between 83 and 89. What is the standard deviation? All right, so if I go to empirical rule, 86, and we're going to go 1, 2, 1, 2. So this is a low of 83, and this is a high of 89. Okay, so we're going 1, 2, 3, 4 standard deviations apart because this is -2 to +2, -2, 0 to 2. So 4 standard deviations apart. Well, if I go 89 minus 83, that equals 6. So from here to here is 6 degrees, but how many standard deviations? It's 4 standard deviations, and 6 divided by 4 is 1.5. So let's check that out. If I add 1.5, this is 87.5. If I add another 1.5, I'm up to 89. 86, I take away 1.5 and I end up at 84.5. I take away another 1.5, I end up to 83. So that all checks out. 52 is B. Populations P1 and P2 are normally distributed and have identical means. However, the standard deviation of P is twice the standard deviation of P2. All right, so if I'm thinking about that, that means P1 is twice the standard deviation of P2. So if P2 is nice and tall, P1 is going to be a little bit short and fat. Or maybe we should use the word husky, probably a little better. All right. don't want to offend people. Um, what can be said about the percentage of observations falling within two standard deviations? Oh, they're the same because it doesn't matter what the mean is or what the standard deviation is. It's 95% for both of them because it's a normal curve. The percentages are identical. That's 53 is E. 54. Which of the following statements is incorrect? Okay, we're looking for a false. All normal distributions, the mean and median are equal. True-ish, because normal is mound shape, and if it's mound shape and because it's mound shape and symmetric, the mean and the median should be equal, so that should be good. A normal distribution is completely determined by two numbers, its mean and its standard deviation. You don't know that, but that is a true statement. All bell-shaped curves are normal. No, that is false. We have different distributions that can be bell-shaped. The T distribution, which we will study later in our next unit, is bell-shaped, and it is not normal. 55. Company 1 manufactures bomb fuses that burn an average of 50 minutes with a standard deviation of 10. All right, so this is company 1, and they have mean of 50, standard deviation of 10. Company 2 advertises fuses that burn an average of 55, so mean of 55, standard deviation of 5. Which fuse is more likely to last at least 1 hour? Okay, 55 minutes. So they're talking, we probably should change that 1 hour to make it 60 minutes. So X equals 60 and X equals 60. And we want the probability that X is greater than 60. And for company 1, my picture is going to look something like this. 50, and we have 60 up here, and we're shading to infinity. For this one, we have 55, and we're shading up to infinity. I'm going to use the norm CDF. I could definitely use stat test z-test. It'll work just as well. So second vars, norm CDF, lower bound. Oh, the lowest thing we shaded was 60. We're going to positive infinity. Our mean is 50, and our standard deviation in this case is 10 for company 1. And we end up getting a probability of 0.1586 for company 2. Second vars, normal CDF, lower bound 60, shading to infinity, but our mean is now 55 and our standard deviation is less, it's 5. And we get 0.1586 also for this one. So approximately the same. All right. So the last 1 hour, 15.9% or 15.86. Pretty close. I like it. C. 56. The distribution of the number of transactions performed at a bank each day is approximately normal. All right. So normal with a mean of 478 and standard deviation 64. Which is the following closest to the proportion of transactions that is greater than 350? All right. So if I'm drawing a picture of this, we have a mean of 478, standard deviation is 64, and they want to know the probability that X is greater than 350. Well, this is 478, 350 is here, but we're shading up because they said greater than, so this is going to be infinity up here. So let's run that thing. And again, we can do a stat test. Let's do that, a stat test, z-test first, just so you don't get out of the habit. All right, my mean in this case is 478. My standard deviation was 64. We're interested in 350, and we're shading up. And I get a probability of 0.9772. 0.9772. Let's confirm that with the norm CDF. Second VARS, norm CDF, lower bound 350, upper bound infinity, mean 478, standard deviation 64, and we get 9772 again. Best answer choice for that is going to be E. All right, number 57. A family has two cats named Gordo and Flacco. Gordo weighs 15 pounds. Flacco weighs 8 pounds. A cat's weight is unhealthy if the weight is located in the top 5% or the bottom 5%. All cat of all cats. The distribution of cat weights is approximately normal with a mean of 9.5. So we have a mean of 9.5 that we're working with for both of them. And we have a standard deviation of 1.5. All right. Well, when I look at Gordo, 9.5, and he's up at 15. So let's check him out. Let's see if Gordo's fat. Second VARS, norm CDF, lower bound 15, upper bound infinity. Mean was 9.5. Standard deviation was 1.5. And boy, he's way up there. So Gordo is unhealthy. All right. Um, let's check on Flacco. Well, I can look at Flacco and go, hey, he's only one standard deviation away. He's not unhealthy. But we'll go and do it anyway. Second VARS, norm, CDF. And his graph is going to look like this. He's at 8. The mean's at 9.5. So we're going to start off at negative infinity. All right. So negative 9 raised to the 99th. Upper bound 8. Mean 9.5. Standard deviation same. And we go, oh, he's at the 15th percentile. He's fine because he said bottom, upper 5, lower 5 is a problem. So Gordo is unhealthy, but Flacco's is not. Flacco's a little bit light, but he's not unhealthy. Fat shaming. 58. The distribution of the number of moths captured per night by a certain moth trap is approximately normal with a mean of 1.01 with a mean of 103. So approximately normal. Mean is 103. If 28% of the capture fall below 76%, 76 per night, which of the following equations can be used to find the standard deviation? Ooh, tricky, tricky, tricky problem. They're telling us this area right here is 0.28. All right. Now we know our mean. We know our mean. And we also know that this score is a 76, but I need that z-score. But I can get a z-score by going second VARS, inverse norm, and 0.28. Oops. Because first off, we're looking for z equals x minus mu over sigma. So I should be writing that first. Back up. Well, I know that this is 76. I know this is 103. I don't know my standard deviation, but I need to know my z-score. So I need to do an inverse norm and 0.28. Mean is 0. All z-scores have a mean of 0, standard deviation 1. And I end up with negative 0.58. Well, the one that looks like that is letter choice D. Number 59. Shalise completed competed in a jigsaw puzzle competition where participants are timed on how long they take to complete puzzles of various sizes. Shalise completed a small puzzle in 75 minutes. All right. So x equals 75 for the small, and a large puzzle in 140. Large x is 140. For all participants, the distribution of completion time for the small puzzle was approximately normal with a mean of 60 minutes. So this had a mean of 60 minutes and a standard deviation of 15. The distribution of completion times for the large puzzle was approximately normal with a mean of 180 and a standard deviation of 40. Now, it's important they told us it was normal. If it wasn't, we couldn't do this. All right. We obviously the question was cut off, but what they want to know is how did she perform relative to everybody else on these puzzle times? So let's find out. We're going to go to the small puzzle first, and so I'm going to draw a picture of it. So the mean is 60, but she's up here at 75, and we want to know how she did. So with that one, second vars, normal, CDF, lower bound, negative infinity. We stop shading at 75. We have a mean of 60 and a standard deviation of 15. So she was 84th percentile on the small puzzle. All right, so this gets rid of those three. We know it's going to be one of these two. Where was she on the big puzzle? Well, she was definitely faster on the big puzzles. The mean was 180, and she was at 140. So let's find that percentile rank. So second vars, normal, CDF, 140. Mean was 180, and the standard deviation was 40. A lot of variance. And here she was at the 16th percentile. All right, so she was at the 16th percentile on the large puzzle and at the 84th percentile on the big puzzle. Huh. Anyway, so the answer to that one, she's the 84th percentile on the small puzzle. Anyway, that's correct. Number 60, the distribution of the number of transactions per day at a certain automated teller machine is approximately normal with a mean of 80 and a standard deviation of 10. Which of the following represents the parameters? Oh, parameters. These are my parameters, and they're always in Greek letters. All right. That's sample, that's sample. Because parameter is for the population. So population parameter. Sample, sample variance. A sample mean, population mean. But population mean, population standard deviation, that's D. And E is the population mean and the sample standard deviation. That's a parameter, parameter. Sample, 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 samples, sample, sample, and sample. All right. It has to be in Greek letters. So, and remember, if it's from the sample, it's a statistic. It's from the population. It's a parameter. All right. I appreciate you watching, and I hope to see you on the next one. Thank you.